Hello students, good morning all of you. So in IP annual examination, the choice is there for asking 8-mark question from 12th chapter, that is thermal properties of matter. So what is our question? State and explain Newton's law of cooling. First point, state the condition under which Newton's law of cooling is applicable, and they are asking one short problem also. A body cools down from 60 to 50 degrees Celsius in 5 minutes and 40 to 40 degrees in another 8 minutes. Then find the temperature of the surrounding. See here. So how could we state this Newton's law of cooling means? Newton's law of cooling means heat losses, right or not? Heat is lost from higher to lower. So what is the Newton's law of cooling? The rate, sir, we are state in two ways. First statement is the rate of cooling of a body, means lot of heat of a body is directly proportional to mean excess temperature of a body over the surroundings. But see, the rate of cooling of a body is nothing but the rate of loss of heat. Heat is denoted with Q. Rate of change of loss of a heat body, this minus indicates the loss of heat body is directly proportional to change in mean temperature of the body and surrounding temperature of the body, theta naught, where theta 1 is the initial temperature of the body and theta 2 is the final temperature of the body and theta naught is the temperature of the surroundings. And in another way also we state this statement. What is that statement, beta? See, theta is nothing but what? Temperature. So how would you define this total Newton's law of gravitation now? Rate of loss of temperature is directly proportional to change in average temperature of the body and surrounding temperature of the body. See right now. So how could we prove? See, so how would you prove this value? Let a body cools from theta 1 degree temperature to theta 2 degree temperature, where theta 1 is, you already know, initial temperature, theta 2 is the final temperature, theta naught is the temperature of the surroundings. Now from Newton's law of cooling minus dq by dt, when we removing this proportional, we are writing one constant term is equal to k. This depends on nature of its surroundings, k into theta 1 plus theta 2 minus by 2 minus theta naught. When we removing proportional, we have to write like this. This is considering the equation 1. From, you already know specific heat. From that specific heat energy is equal to, what is the formula? Ms theta. So with respect to time, this heat energy we are writing like the dq by d theta is equal to ms is constant, then d theta by dt. We already know according to specific heat concept. Then from equation 1 and 2 we get, what is the equation 1 here? See, minus dq by dt. We are already finding this value. Replace of dq by dt, we are writing ms into dq d theta by dt is equal to, remaining term is k into theta 1 plus theta 2 by 2 minus theta naught. Now this term is transposed to RHS side, then we'll get this value is equal to k by ms into theta 1 plus theta 2 by 2 minus theta naught. Here this total term is constant. The term is, we are taken k or b as your wish. This is the constant term, right? Now remaining concept is minus d theta by dt is equal to k into theta 1 plus theta 2 by 2 minus theta naught. So this is the statement and the explanation of Newton's law of cooling. Now what are the conditions of Newton's law, where it is applicable for Newton's law of cooling? So Newton's law of cooling is applicable, first, loss of heat by conduction and radiation is neglected and due to convection only is considered. What is the mean of conduction? Without changing the particles of the medium, without changing the medium, So particles will smooth without changing the particles of the medium. So heat transmits from one place to another place. Radiation without using any medium, heat transmitting from one place to another. But what about convection? With changing the particles of the medium, in a bowl we should be taken to the water. When will heat is applied means what will happen? Particles are moving from upper to downer. So means here particles are moving, but here not moving. In a metallic rod, they are collide to each other and heat transmitting from one place to another place. Radiation means from sun to earth. We are not using any type of medium. So only laws of heat observe only in convection, not in conduction and radiation. Second one, the temperature difference between body and the surrounding must be more than 30 kelvins. Must not be more than means that is below 30. Third one, temperature of the body is uniformly distributed over it. And last point is laws of heat occurs in a streamlined flow of air. Next, last point is problem. They already given temperature. A body is lost from temperature 60 degrees to 50 degrees. Means initial temperature is θ1 is equal to 60 degrees, θ2 is equal to 50 degrees. Temperature of the surrounding. So how could we find? That is θ0 is equal to how much? Then time is equal to first 60 to 50. They are taken to the time is 5 minutes. According to Newton's first law of cooling, what do you know? This formula, dθ by dt is equal to k into θ1 plus θ2 by 2 minus θ0. Then θ1 is 60 minus 50 by 5 is equal to k into θ1 plus θ2 by 2 is nothing but 60 plus 50 by 2 minus θ0 or by. So what is the value of difference in temperature is nothing but 60 minus 50, 10 by 5. 60 minus 50, 10 by 5, right? Is equal to k into 5 minus θ0. In second case, it takes 8 minutes to fall from 50 to 40. 50 to 40 means again using Newton's law of cooling, dθ by dt. What is the difference? 50 minus 40 by how many times? 8 is equal to k into θ1 plus θ2 by 2 minus θ0. So 10 by 8 is equal to k into 45 minus θ0. By solving from 1 and 2, we will get. So 1 by 2 will get what could you do here? First equation 10 by 5 is equal to k into 55 minus θ0 by. Second equation is 10 by 8 into k into 45 minus θ0. So from this we have to find the θ0 value. K terms are cancelled. Now when we are simplifying this total, then finally we will get the point is, what is that beta? So 85 is equal to 3 θ0. From this we have to find the θ0 value is equal to 28.33 degrees Celsius. This is the point. Thank you.